is Miss Hess here. Today we're talking about linear functions, and specifically 3.1, graphing linear inequalities. So we're going to start off today looking at two graphs. The first graph, example 1, is the line y equals negative 4x plus 1. Before I graph this line, I already know a couple things. I know I have a slope of negative 4, and I have a y-intercept of positive 1. So I can graph this function by hand, or I could just plug it in my y equals in my calculator, graph it, and find my points. I'm just going to go by hand here, and I know I have a y-intercept of 1 and a slope of negative 4. 1, 4. Okay, so I'm just plotting those points based on my slope, and I can go ahead and connect these to form my line. So here we see our line with a y-intercept at 1 and a slope of negative 4. For example 2, we have the same slope, the same y-intercept, but now we have an inequality symbol. So we're graphing the line y less than negative 4x plus 1. So I'm going to use the same approach. I'm going to treat this like it's an equal sign at first. So I'm going to plot my y-intercept at positive 1. And from there, down 4 to the right 1, and plot my points from my slope. Again, you could just plug this into your graphing calculator and find those points. We can do this pretty quickly here. Okay, I'm going to stop there. Okay, so now I need to think about what the difference is between these two lines. Okay, so the difference between these two lines is our solution set. And I'm actually going to write that here. So the difference is the solution set. So on the left-hand side, our graph of y equals negative 4x plus 1. The solution set is just our line, everywhere on the line. So the solution set, I'm going to write SS for solution set, is the line. So all points that lie on the line. For the graph y less than negative 4x plus 1, our solution set, SS, is going to be a shaded region of the grid, of our coordinate plane. So I'm going to show you what I mean by that. First, I'm going to pay attention to my inequality sign, and this is a less than sign. So because it's a less than and not equal to, everywhere on my line, when I connect these points, is not included in my solution set. So I need to show that by using a dash line, and this dash line indicates not equal to. Okay, so we use a dash line. Not very straight, but we use a dash line to show that. Okay, that's the first thing. Then the second part is this shaded region part that I need to pay attention to. So looking at my inequality sign, my y is on the little side of the inequality sign, so that is less than. So I want to shade the portion. I want to shade the portion of this graph, all my y's that are less than. So less than would be, if I go to my y-intercept, this is here, I want to think about all of the y's, all those values that are less than this one. So I would shade down, or in this case, in this direction, and when I shade, I use just straight lines. I don't color it all in. Just some simple lines like this is enough to show that everywhere to the left or less than is part of my solution set for this graph. Okay, so now just to recap and to look ahead a little bit, things to note. Again, for inequalities, we have 4 different cases. We talked about this case, the first one, where y is less than. We shaded below, and we used a dotted line or dashed line. We also have 3 other cases. We can have y is greater than, and then we also have y less than or equal to, and y greater than or equal to. Both of these would be solid lines, not dashed lines. We're going to see an example of that next. Also, one more thing to note, when when it's just y equals, we do not shade. We do not use a dotted line. It's just one solid line. So looking at now number 3. So we want to graph the line y greater than or equal to negative x minus 4. And so again, I just want to graph this one like normal. I have a y-intercept of negative 4. So 1, 2, 3, 4. Place our y-intercept. And we have a slope of negative 1. So I just go down 1 over 1. Okay, and I can create a bunch of points. I need to make sure I get them on both sides of my y-intercept. Okay, and again, you could just plug this into your graphing calculator and just pick certain points and plot those key points. I like to have enough points so I see a true representation of what the line is doing and I span most of my grid. So I'm actually going to extend this a little more. Okay, great. So I've now graphed the line. Okay, y greater than or equal to negative x plus 4. Now notice for this one, I did not use a dashed line because we have y is greater than or equal to. When I'm equal to, I want a solid line. Okay, now we come to the dilemma of shading. So I want to pay attention to where y is, my sign. Y is on the greater end side, the big end of my inequality. So I'm going to be shading above. So I always like to just go and note where's my y-intercept and where are all the y's above that point if I'm shading above. So above is going to be in this direction. So I'm going to shade everywhere above the line this way. Okay. And this would be my solution set everywhere that is shaded. So actually to show my solution set, I'm going to just put S, S, and the SS again just stands for the solution set of this inequality. Okay, so the solution set again would be everywhere on that solid line because it's a solid, not dashed, and everywhere above that line. So that would be my solution set. Looking at next, number 4. The first thing I noticed with number 4 is that this is not in slope-intercept form, meaning y is not isolated, y is not by itself. So before I do anything, I want to go ahead and get this into slope-intercept form. So first thing I could do is inverse operation, subtract 5x, and I'm left with negative y is greater than negative 5x plus 2. It's a positive 2, so I add 2. Okay, I'm not done yet because I have a negative coefficient in front of my y, so I can go ahead and divide by negative 1 and divide everything, each term on the right-hand side by negative 1. Okay, when I do, that negative cancels out and I'm left with y. Okay, careful here, we have a sign change. Because I divided by a negative, my sign is now going to flip and become less than. Okay, simplifying this, I have a negative 5 over negative 1 and a 2 over negative 1. So my negative 5 over negative 1 becomes positive 5x. 2 over negative 1 is minus 2. Okay. So I've rewritten this linear equation, this linear function, to be y less than 5x minus 2. Okay, now I can go ahead and graph again as normal. So I can go to my y-intercept, negative 2, and I have a slope of positive 5. So I go up 5 over 1, up 5, 1, 2, 3, 4, 5 over 1. And I want to make sure to get both sides. Okay. And before I go ahead and draw my line, I have my dots. I need to think, stop and think, what is my sign? My sign is less than. I do not have an equal to underneath. So remember, for less than, we are using a dotted line, and we are shading below. So my dotted line, I'm going to go through points, okay, using a dashed line this time, not a solid line. And be careful, you need to span your entire grid. Okay, so see how I went from down here to up here. I span the entire grid, and now I'm going to shade. So shading below, again, looking for that y-intercept, thinking about all the y's below that point. So that's in this direction. Everywhere where I'm shading is a solution. Okay. Everywhere here is a solution, but no point on this line is a solution because it's not equal to. Okay, so I'm again going to show that I know where my solution set is. I'm putting SS for solution set, and I'm done. Okay, so that about covers this lesson. In this lesson, we just looked at graphing linear inequalities. In the next lesson, we're going to talk about systems. So please, one thing to just pay attention and remind yourself are these notes. You really should know those, have those memorized. Please pay attention to if it's an inequality and if you have an equal to or not. See you next time.